Hello, my name is Resul Ayberk Şahpaz and I am a second year physics student at Bilkent University. In this video, I will be presenting the project spectral analysis of different light sources which I was worked with my friends Osman Kalın and Arda Tayishilova for Physics 212 course. The aim of this study was to investigate the unique spectral signatures of various light sources using a simple handmade DVD spectrometer. By doing so, we aim to demonstrate the fundamental differences between continuous and discrete light spectra and illustrate how low-cost equipment can reveal the core nature of light. Spectroscopy has a long history starting with Newton's use of a prism in 1666. Later, Kirchhoff and Bunsen discovered that atoms emit light at specific quantized wavelengths, providing early evidence for the quantum nature of energy. The core of any spectrometer is a dispersive element. In our case, we use the standard DVD which acts as a reflective diffraction grating. Because of its track pitch of approximately 740 nanometers, it causes constructive interference at specific angles, separating light into its constituent wavelengths. Our setup was housed in a 3D printed frame utilizing narrow 0.5 mm slit and a razor blade to ensure clean single slit interference. To analyze our data, we used two different Python programs. The first was a simulation tool based on Planck's law and Wien's law to calculate the expected theoretical spectra for sources like the Sun. The second program was used for digital image analysis. We took photos of the spectra with digital camera and used our algorithm to extract intensity data from the RGB color channels. This allowed us to quantitatively identify spectral peaks and compare our experimental data directly with our theoretical models. In our experiments, we observed the stark contrast between different sources. Sunlight showed a continuous spectral distribution with strong intensities in the blue and green regions as expected. Conversely, when looking at gas discharge sources like fluorescent and mercury vapor lamps, we observed discrete emission lines. For example, in the mercury gas tube, we successfully captured the characteristic green spectral line between 540 and 560 nanometers. While we encountered some algorithmic limitations when reconstructing continuous spectra from RGB data, the results for discrete transitions were quite accurate. In conclusion, our project proves that even a handmade diffraction spectrometer can effectively identify the physical properties of matter and light. This work serves as a practical bridge between theoretical quantum mechanics and experimental observation. Thank you for listening.